In this problem, we're given a quadratic function, and we're asked to find a simplified expression for f of x minus 2 and f of x plus h. So for part A, what I like to do in these problems, where I'm asked to take a function and evaluate function notation, wherever I see an input variable x, I replace it with a set of parentheses so that I can later fill in the parentheses whatever it is I'm asked to input in place of my input variable. So in my case, that would be x minus 2. So notice, if you took what I was written and you simply put an x in the parentheses, it would match the given function. That's what an input variable is a placeholder that will later take on numerical values or algebraic expressions in this case. But what this notation says is wherever you see the input variable x, please replace it with parentheses x minus 2. I often denote this with my students with this notation that suggests all we're doing is making a symbol swap. Wherever you see this symbol in the given information, replace it with all of this. So since they want me to do the problem f of x minus 2, I will fill in the blanks the algebraic expression x minus 2, and if I didn't need to simplify, I'd already be done with the problem. However, it did say find a simplified expression, so I'm going to need to multiply this all out. So I'm not going to take any shortcuts here. I noticed that the quantity x minus 2 is being squared. That means that x minus 2 is being multiplied by itself. So you may recognize this as what some teachers call a foiling problem. I may at this time decide to distribute the 4 for x, and then 4 times negative 2 is negative 8. And I also copy this negative 8. Usually what I do to simplify this part, because you do have a couple choices, I usually FOIL out these two binomials first, and then at the very end distribute the negative 7. So to do that, I would copy the negative 7 and copy everything else in the problem except for the multiplication of these two binomials. Here's where we FOIL. X times x gives x squared. Negative 2 times x is negative 2x. Here we get another negative 2x. And negative 2 times negative 2 is positive 4. Now that negative 7 was being multiplied by all of this. Before I multiply the negative 7 through, you may want to combine the like terms inside the parentheses, and we can also take care of this over here. So in the parentheses we'd have x squared. These combine to give you minus 4x. Copy the plus 4x, and negative 8 subtract 8 will give you negative 16. Now I'm going to distribute the negative 7. That gives you negative 7x squared. Negative 7 times negative 4x is positive 28x. And negative 7 times 4 is a negative 28. So we'll be subtracting 28 here. Copy the rest of the problem, combine like terms, and we will be done with part A. This is the only term with x squareds, so I will copy it. 28x and 4x add together to make 32x. And finally, a negative 28 and a negative 16 together make a negative 44. So we will subtract 44 here. So this was my simplified expression, and I've done so much work here we may have lost how we got this. So what exactly is this answer that we got? This is the simplified expression for f of x minus 2, of course only if f of x is this function here. So now I'm about to do the same thing with part B. Every step will be the same, but it will play out a little differently because it's simply a different problem. So notice for part B, I've written the exact same thing I did when I started part A. I copied the original function, and wherever I saw the input variable x, I left a blank space with parentheses for which I can now go in and fill in whatever they want me to replace the input variable with. In this problem, the variable x is going to go away, and we are going to replace the variable x with parentheses x plus h. So I will put an x plus h here. That gives me the question, f of x plus h. And since I put x plus h in this set of parentheses, I must also put it here. And I'm going to work it out the same as I did the last problem, where I noticed that this really says that we have the binomial x plus h multiplied by itself. That's what squaring means. And I'll distribute the 4. I'll get a positive 4x, and I will also get a positive 4h. And I will copy the subtract 8 at the end. Just like in the last part, I'm going to decide to copy the negative 7, multiply that all out, and whatever that simplifies down to, I will distribute the negative 7 to all of it. There are no like terms over here, so I'm just going to copy them. They cannot be combined. And I will FOIL these two binomials. X times x gives x squared. This multiplication gives xh. This multiplication gives you hx, but since multiplication is commutative, I will write it as xh, just to make it clear that these two things are like terms. Finally, I get h times h is h squared. My preference is to simplify what's in the parentheses before I distribute the -7. So since I have 1xh and I'm adding another 1xh, that makes 2xh. And again, nothing over here are like terms, so there's nothing more that I can do than copy them. Distributing the -7, I get -7x squared. -7 times 2 is -14, so I will write -14xh. That plays out as subtraction down here. -7 times h squared is -7h squared, so I will write subtract 7h squared. And you may notice that none of these terms are actually like terms. This is the only x squared term I have. This is the only term that involves xh. This is the only term that involves h squared. This is the only term that has just an x in it. And this is the only term that has just an h in it, and that is just a number. Since there are no like terms, there's nothing to combine. Don't forget that all of this came out of the fact that we were evaluating the function at x plus h. So you should write the question and the answer to remind yourself what it is you actually have found. It turns out that this notation here, f of x plus h, ends up being one part of a larger problem in college algebra and calculus. Hopefully this made sense, and best of luck with your problem.